Hi, today we'll see the magnetic field due to current through a circular loop. Okay, so what we are going to do means we are going to take a circular loop. Okay, imagine that this is a circular loop. Okay, imagine that this is a circular loop. Okay, this is a copper wire. Okay, bent into a circular shape, and the distance equal to the diameter of this circular loop. Make a hole and insert this into the cardboard. Okay, imagine that this is a cardboard. Imagine that this is a cardboard. Okay, we are going to connect this other ends to the battery, key and everything. Okay, to pass the current. Okay, so it will be like that. Okay, it will be like that. Imagine that it will be like that. So once current has been passed, how the magnetic fields will be formed. Okay, once a current is passed, the magnetic, since it looks like a straight line, right, straight conductor, then how the pattern will be formed. It will be concentric circle, right. It will be around the conductor, right. How it formed in the straight conductor, right. So it will be around the conductor. It will be concentric circles near the conductor. Likewise here also it will form a concentric circles. Okay, okay, it will form a concentric circle when it is moving away from the conductor. It will be, the gap between the coils will be larger and larger, like this. It will be larger and larger. At the middle, the bigger circle will looks like the straight line, because it is a bigger circle, so it forms a loop like this. Okay, but when it is considered here, it looks like a straight line. Okay, it's look like a straight line, and but around this one it will look like a circle. Okay, and this direction of this magnetic field can be found using the right hand thumb rule itself. Okay, for example, the current is flowing from here to here, from bottom to top, means that means you have to hold like this. Okay, the hole like this. So the current, the thumb will show the path of the current, and my fingers, it is towards this. So the path will be, it will be like this. Okay, the path of the magnetic field direction is like this. Okay, when it is down, it is passing through this, right. When it is down, it will be like this, right. We will be holding like this, the downward direction. My thumbs are like this. Okay, so it will be moving in this direction. Clear on this? Clear on this? When it reaches this place, here it will be in anti-clockwise direction. Here when it reaches this center path, both will emerge in the same direction. Okay, both will emerge in the same direction. Clear on this? This is how the magnetic field be around the loop. Okay, so a copper wire is bent in the form of circular coil, and two holes are made in the stiff cardboard equal to the diameter of the coil. Okay, the wire is placed through the holes and the cardboard is clamped into the wooden stand. Okay, ends of the coil is connected to the battery through a key. Okay, fine. How the lines will be? The magnetic lines of force near each segment. Two segments in the circles we have seen. No, it is near the segment. It is the near each segment of the wire are circular and form concentric circle. How it be? Near the near each segment, it forms a circular and form concentric circle. The magnetic lines will be circular and forms a concentric circle. The magnetic lines of force near the center of the coil is almost straight line. What? It is almost a straight line, because it form a greater circle. So it looks like almost a straight line at that place. Okay, the magnetic lines of the force near the center of the coil is almost straight line. Okay, the direction of the field lines can be found by applying right hand thumb rule, that is Maxwell corkscrew loop. Okay, okay, fine. Okay, we have seen how to find the direction of the magnetic field as well as how the magnetic field has been formed. Okay, now we will discuss about the magnetic field strength. Okay, the magnitude of the current kind circular loop. Okay, it depends upon various factor. The magnetic field depends on the following factor: based on the radius of the coil. Okay, based on the radius of the coil, based on the number of turns, the amount of current flowing through that. Okay, if the radius of the coil if the radius of the coil increases means then it the strength will be decreases. Okay, the magnitude is inversely proportional to the radius of the coil. Okay, if the radius is small means then you will have more strength. Lines will be like this. When it is big means it is far away from the center as well as these things. Okay, then the strength will be reduced. Okay, it is inversely proportional to the radius of the coil. That is, if the radius increases, the strength will be decreases. Okay, and also the number of turns. Only one wire is turned in the form of circular. Again, one more is turned up means then if we turned up into circular form, if we increase the number of turns like this, number of coils like this, number of turns like this, then it is directly proportional to the strength. Because if these number of turns will have the flow of current in the same direction, so it will add up and it will give more strength. Okay, the number of turns of the coil is directly proportional to the strength. That is, if the number of turns increases means strength will also increases. Okay, next, amount of current flowing through that. We know that it is directly proportional. The magnitude of the field is directly proportional to the amount of current flowing through it. That is, the current increases, the magnitude of the magnetic field will also increase. Okay, thank you.